I got your question here about a certain flight. 75% of the time arrive on time. 75% of the time. So that's your P here. You know, P would be 75%, and if we make it a decimal, 0.75. Suppose 189 flights are randomly selected. So that's going to be N. N is the number of flights here, number in sample space. So 189 flights are randomly selected. Use a normal approximation to the binomial to approximate the probability of the following. Part A is exactly 147 flights are on time. Well, first thing you got to do is find out if this thing's going to be approximate a normal distribution, and so this is the test for it. N times P times quantity 1 minus P has to be greater than 10. So I went ahead and put in the numbers. N was 189, P's 0.75, and I get a little over 35, 35.4, which is greater than 10. So we can proceed. If not, we would have to stop here. So the mean, this gives you the mean flight time. So the mean flight time is N times P. I went ahead and calculated N times P, and I get the mean flight, I guess, on time would be 141.75. Okay, so 75% flights are on time, and you have 189, and that's how many flights you expect to be on time. Then the standard deviation is given by this formula: square root of N times P times quantity 1 minus P. So I put the numbers in. Standard deviation for this case is 5.953. Okay. We want to find out, what's the odds of what's the probability of having 147 flights on time, which that's above the mean here, out of 189 flights. And so the probability of 147 flights on time. Now, if you look at your handouts or you're looking at your book, they tell you how to calculate the exact probability, using the normal curve, and you want to add and subtract, 0.5 to this. And so to calculate this, you don't have to calculate the probability that it's between 146.5 and 147.5. So you just subtract, first of all, 0.5 and add 0.5 to that. And now we don't have to convert this to z-scores, and then we can either look on the table or use your calculator to find the probability. So I need to find the z-scores for 146.5 and 147.5 based on the mean and the standard deviation I have here. So let me move this up a little bit. So I need to calculate the z-score. So I start with 146. The z-score would be 146.5 minus the mean over standard deviation. And, I'm getting these right here is this number, the two other numbers right here, and I calculate it and I round it, round the z-score to two places, and so that'd be 0.80. I need to repeat this for the 147.5. So I just redo this, find the z-score for 147.5. I'll put that in the calculator. You want to round to near two decimal places, or nearest hundredth, and I've already done that. That's 0.97. So this probability here, I come over to the side here. If I translate that into z-scores, it would be a probability that the z-score is between 0.80 and 0.97. So you need to look each of these up. Well, I just looked them up in the table here. I looked up 0.97, and it was 0.834 minus, and I looked up 0.80 in the table. It's 0.7881. Again, 0.80 in the table was this value, and 0.97 was that value. Oops, that should be less than or equal to. And so you subtract those two values, and I get 0.0459. Hope this helps.